Okay, in this video we're going to be talking about algebraic functions and trig functions, trigonometric functions. I'm going to start, we're still in section 1.2 of Stewart's Calculus, 7th edition, early Transcendentals, and we're nearing the end of the section. He's talking about all these different functions, and here I'm basically at the end, and he's talking about algebraic functions and trig functions, and these go quick, so I'm just decided to include both of them. Algebraic functions are really just functions that are constructed using, addition, subtraction, multiplication, or division. So because division is involved, any rational equation or function is automatically considered an algebraic function. Okay. Now, root functions are considered algebraic functions, especially if they have plus and minus under the radical, and plus here. So this is all algebraic functions, and these functions, what's important to know about them is how to find their domain and range. You can easily find the domain here and the range just by knowing the square root function. Here, it might be a little hard to find domain and range. It would be really hard to plot this if you're just using pen and paper. But as we can see here, the domain can't be 0, because if x equaled 0, you'd get 0 here and 0 here, and you'd have a 0 in a denominator for the entire equation, and that cannot be. You also notice that anything less than 0 is unacceptable as well. And I'm going to show the graphs of both of these. I got these from the book, by the way. I'm going to show the graphs of both of these right now. Okay. This is the graph of square root x squared plus 1. Not exactly the regular square root function graph that you know, but this is what that looks like. This is an algebraic function graphed. Here's the second one, g of x. I'm going to zoom out too so you can see the entire thing. You'll notice my increments, they go by 8s, 8, 16, 24, 32. So this function's kind of big. It goes way down and then it goes up. And as you can see, like we said, the domain, this function is not defined at 0 and beyond. So you only see it on the right side of the y-axis, where x is equal to 0. And now for the trig functions. You should know the trig functions already and their graphs from Algebra 2 or pre-calculus or your trig class. So this is sine x, right? It goes through the origin, goes up to 1, and I should change the, let's see, I forget, is this at Siska? Yes, okay. So the graph of sine and the graph of cosine, which is this darker one that I just put up, their range is from 1 to -1. Sine goes through the origin, it crosses pi, and it has a period of, if I remember correctly, yeah, x plus 2 pi. So sine of x plus 2 pi, or sine of theta plus 2 pi, is the same as sine of theta or sine of x. Alright, so you have 1 same to 2 pi. That's called periodicity. Cosine is the exact same thing, periodicity-wise. It doesn't cross the origin. Instead, at 0, it crosses 1. Its range is from 1 to -1. Okay, periodicity is 2 pi, or you can think of it like that, 2 pi. It ends up at the same place. And then from the sine and cosine functions, we can get the tangent and cotangent functions. This is tangent x or tangent theta. You'll notice tangent crosses the origin. Okay, it has a period of pi. Cotangent is backwards and it does not cross the origin, unlike tangent. It too has a period of pi, like that. Okay, and though, by the way, tangent and cotangent are just the ratios of sine and cosine. You should know this already. Secant and cosecant. This is the graph of secant. Look, its range is the exact opposite of that of sine and cosine. Okay, instead of 1 to -1, it goes from 1 to infinity and -1 to negative infinity. And actually, this is very interesting. Look at secant. Look at the graph of secant, and then look at the graph of cosine. Both of these graphs touch each other at pi intervals. Okay, so now look at cosecant, which is just, you know, a translation of secant. I was about to say transition. And cosecant does not touch the y-axis or x equals 0. It too has a period. Well, it has a period of 2 pi. So up here, down, and then at 2 pi it repeats. Then down, just like secant. Secant has a period of 2 pi as well. Now look at cosecant and sine. They touch each other at pi over 2, negative pi over 2, and so on. So that's just some things to remember. You should know all of these already. All of the trig graphs. That's an amazing picture, actually. Functions are so amazing, especially trigonometric functions. You can make some really interesting patterns and designs with these. So I believe this is actually the last functions. Oh, no, we still have exponential and logarithmic, so I'm going to do those in the next video. Alright?